Okay, thanks, Trish. First of all, can everybody hear me?
Yep, I can hear you, Jim.
Okay, good. And I'm not seeing any. If you have any questions, yeah, good. Thanks. Don just responded with yes. So if you have any questions, certainly type in your message, and as we're going through this, we'll try to address maybe in real time. Today's presentation, what I'd like to do is we're actually going to be discussing a couple of our SBCA research reports. The first one that I want to take a little bit of time going through is the SRR number 1509-01. That's Fire Resistance Rated Truss Assemblies, the title of this presentation. But I also want to touch briefly on the SRR 1509-02, which is a calculation of the 2-hour fire endurance assembly for metal plate connected truss, structural, floor, and roof framing systems. And then finally, discuss a little bit about fire retardants and truss design. So basically, I'd again like to thank everybody for taking the time to be with us today. It's a little after lunchtime here, 1 o'clock. We're in Madison, Wisconsin, so hopefully you haven't had real big lunches or eaten turkey or anything like that, because I don't need to be fighting uphill anymore in terms of giving a presentation and putting everybody to sleep. But anyway, we'll go on and see how things go. Again, though, if you have any questions, please feel free to interject at any time. So basically, the obviously building codes may require that a fire endurance rating for an application, specific applications involving metal plate connected wood trusses or trusses, have to have the assembly has to be have a fire endurance rating, and that can be a floor ceiling assembly, that can be a roof ceiling assembly, or for an attic separation. The generic fire-rated wood truss assembly would be typically look something like this. Now this happens to show floor truss, or what appears to be floor truss, parallel core truss, and basically is going to include the, in this case we're calling a gypsum board, but it would basically be the protective membrane. In this case it also has, it's attached with to a hat channel, which in turn is attached to the bottom chord of the truss. This particular assembly is showing insulation that is basically being supported on the hat channel. And then you've got the truss itself, the framing member, and then the floor sheathing in this case, or the roof sheathing, the structural sheathing. Again, this is just kind of the general guts of an assembly. Truss protection in fire resistance rated assemblies is covered in the building codes, has been for quite some time, and we're going to be basing everything off of the International Building Code. The IBC states that requirements shall be based on the results of full-scale tests or combinations of tests or approved calculations based on such tests that demonstrate fire resistance, and that's in section 704.5 of the IBC. Actually has some additional information that talks about, for trusses. Before we continue, I'd like to just go over a couple of key definitions from the building code. First of all, what's an approved source? Well, that's defined as an independent person, firm, or corporation approved by the building official who is competent and experienced in the application of engineering principles to materials, methods, or systems analyses. Fire resistance is defined as that property of materials or their assemblies that prevents or retards the passage of excessive heat, hot gases, or flames under conditions of use. And fire resistance rating is defined as the period of time a building element, component, or assembly maintains the ability to confine a fire, continues to perform a given structural function, or both, as determined by the tests or the methods based on tests prescribed in Section 703. So in Section 703.3 of the IBC, there are 6 different methods that are allowed for determining the fire resistance. Number 1, first method is fire resistance designs documented in approved sources. Number 2 would be prescriptive designs of fire resistance rated building elements, components, or assemblies as prescribed in Section 721 of the IBC. Number 3 would be calculations in accordance with Section 722 of the IBC. Number 4 would be engineering analysis based on a comparison of building element, component, or assemblies designs having fire resistance ratings or determined by the test procedures set forth in ASTM E119 or UL 263. Number 5 would be alternate protection methods as allowed by Section 104.11 of the IBC. And then finally, and this is new to the 2015 IBC, is fire resistance design certified by an approved agency. So method 1, documented fire resistance designs. Basically these would be the fire rated assemblies that say are listed in UL, Gypsum Association or others. To qualify as a documented design, testing has to be performed. The testing is conducted in accordance with ASTM E119, which is standard methods for fire tests of building construction and materials, or ANSI UL 263, which is the sister standard that with the UL that UL follows. When you're doing a fire test, the tested assemblies may be specified where a rated assembly is required. So in other words, if you test for a 1-hour rated assembly and you pass, then that would be an assembly that can be used in 1-hour rated applications that require 1-hour rated assemblies. The assemblies can generally be applied to both floor and roof applications. Obviously, if the assembly was tested with 2330 seconds wood structural sheathing as the subfloor material, and you want to use that assembly in a roof, that's what you're going to have to use. Now, some documented fire resistance designs, there are several sources. One would be the Gypsum Association and their Fire Resistance Design Manual. And there is an online manual. It's a read-only, but it's obviously really great now with the internet. We can easily search, and most of these documents we can at least look at on the internet without having to buy the full-blown document. Another obviously very popular source would be the Underwriters Laboratories. They actually have a searchable database online. It's their fire resistance directory. And also many of the UL tested designs can also be found in the product literature of the companies whose products are certified to be listed in the various assemblies. There are other sources of documented fire resistance designs, and remember, you know, it's got to be by an approved source. And some of these approved sources would be Warnock-Hersey, Factory Mutual, and PFS Corporation, which is headquartered right here in Madison, to name a few. One of the documents that we've put together here through SBCA is this research report, SRR 1509-01, which basically includes simplified summaries of the fire-rated assemblies using metal plate connected wood trusses. The original document was put together, boy, I want to say about 4 years ago. maybe even longer than that, and I think it was about a 7-page document. The latest and greatest, and what you have here is you can see the cover. Maybe you can't read it very well, but the latest and greatest was updated in September 21st of 2016, so a little over a month ago. And it is now a 35-page document, I believe. And it obviously continues to grow. So this document, you can go to the website and download it. And before I go on, I guess I just kind of want to make sure everybody that's on this call is aware of this. If you go to the SBCA website, and the web address, if you type in sbcindustry.com, that's sbcindustry.com, you go to the home page, there's a black strip across the top, and the very last menu item says technical. If you basically click on that, that proceeds to a drop-down menu, and you want to go to, from technical, you go to publications. That then also opens up a drop-down menu, and from there you go to research reports, and that will take you to the research reports page, where there are currently 32 reports listed that cover various topics involving trusses, wood trusses. You can scroll down and find report number 1509-01. And if you click on that report, first of all, it opens up a brief summary of what's in the report or what the report is about. And then it gives different options, one of which is you can download the report, which is a PDF. The nice thing about that is when you download it, all of the links in the report are hot, so the various, some of these items that you'll see in this presentation that are underlined and in red, in the report, you can actually click on them and it'll take you to the actual document that's being referred to. You can also go to the, there's another option typically is there's an educational program, which when you click on that will give you two options, one of which is there's a PowerPoint presentation that has been developed that's based on the report, and that is either available as a PowerPoint or you can get the slides in PDF format. For those of you that maybe, and I know there are some truss manufacturers, engineered wood people involved in this call, if you're ever giving presentations, whether it's like a lunch and learn type of presentation at an architect's office or whatever, it's pretty handy. You can actually give a presentation regarding the report. And then many times there's some type of an installation guide or design guide option that will take you for some of the reports. It basically is going to give installation instructions and safety information. In this case, this particular report doesn't have that because obviously we're not going to go through the installation and safety of every one of the assemblies that's listed in the report. But then in many times too, for a lot of the reports, there's, for the building code officials, there's installer and building code official checklists that are available, so they can basically follow the steps to make sure that if it's a research report that involves some type of an installation, then they're installing it correctly, and then the code official has a checklist that they can, as they're inspecting it, can make sure that things were done properly. Okay, I digress there, apologize, but basically when you, the thing to know about this report is we're including the simplified summaries of the various assemblies that we're aware of that involve metal plate connected wood trusses. But the users must consult the listed testing agency's documentation or tests for complete listing information. And I say that because I spoke with an architect a couple of weeks ago who said that they were really interested in using one of the assemblies because it didn't require a finished flooring, in this case a gypsum layer on the floor. However, when they went to the UL, it happened to be a UL report, when they went to the actual report, it was, that was not an option. It required a finished flooring. And so, and you probably can't read it very well, but the in red right above this table, and this is on page 7 of the report, it just reiterates what I just talked about, and that, hey, these are summaries, you still have to go to the report number. Now, the information in this document is basically provided based on, first of all, in the kind of a turquoise or what blue-green strip on the very left-hand side of the table. It lists by the assemblies by, first of all, the endurance rating. So in this case, we start with a 1-hour rated assemblies. The category the next column in, and in this case, if you can read that, it says floor. So on the first page, this would be 1 hour, no insulation in these assemblies. They were tested without any insulation. Category is floor. Then we show kind of an illustration that shows kind of what the assembly looks like, and then we describe the construction, and that typically includes what the on-center spacing is, the minimum depth of the truss member, the amount of what the membrane protection is, such as 2 layers of 1/2-inch Type X gypsum. Minimum sheathing for the very top one is 1930 seconds, and that is based on the Gypsum Association FC 5512 report. So if you want to know what the specifics of each of that particular assembly is, you'd have to go to that report. Now, the other thing that, the reason I'm showing the first page of this is, if you look at the top here, it basically provides a key for who the certifying agency is. GA stands for Gypsum Association, NER, National Evaluation Service Report, PFS Corporation, so on and so forth. And then it also kind of defines what some of the symbols are that are included in the illustrations. So it's actually, this document is, I think, pretty handy in terms of, yeah, you could, if you have a UL report or fire resistance directory or a Gypsum Association document, certainly you've got all that information at your fingertips. This is kind of nice because it does provide all the different assemblies, and it goes from a 1 hour, 1.5 hour, up to a 2 hour, as well as the separation, area separation assemblies, say for up in attic spaces, or at if the wall is framed with a gable end frame or a gable end truss, what assemblies are allowed for that, or separation assemblies. Okay, so method 1, documented fire resistance designs. In general, the fire resistance rating of the listed assemblies applies to the entire assembly. Okay, so it's not, you're not getting a 1 hour rating on the floor truss. It applies to the assembly. And with the tested assemblies, the components are not intended to be interchanged between assemblies. So an assembly that was tested with I-joists would not necessarily apply if you wanted to use metal plate connected trusses and so on and so forth. However, method 4 of the IBC, which allows for engineering analysis and comparison, does allow evaluation by comparison of tested assemblies. That is permitted in the IBC. Now, in order to do that, someone has to, make the case, and then ultimately the building official would have to approve or agree that, yeah, okay, in this case, I think that, we can go ahead and switch out these components or whatever, and we'll still maintain the, be able to get a 1 hour rating. Another couple of things about the documented fire resistance designs is, first of all, the depth and spacing. Depths basically are typically given as minimum. So like you'll see with I-joists, minimum 9.5 inch. So anything deeper, if they want to use a 14-inch deep I-joist, or in this case, like trusses, 12-inch deep, and they want to use a 14, or the truss assembly is going to use a 14-inch deep floor truss instead of the 12 that was originally tested, that's fine, because typically the greater the depth of the assembly, the more plenum space you have, and so the more area you've got to dissipate the heat if a fire is occurring below the ceiling line. And then also the on-center spacing, typically that's listed as maximum. So if the assembly was tested at 24 inches on center, but the actual product is going to be used at 12 inches on center or 16 inches on center, that's fine, the assembly would still apply. Question that comes up quite frequently has to do with insulation. And when you're trying to look at these tested assemblies, some assemblies will allow the addition of insulation if an additional layer of gypsum is installed at the ceiling. For instance, if you're looking at an assembly that meets the 1 hour using 2 layers of 5/8 type X, and you want to use insulation in that assembly, and the assembly that you are interested in using or the building designer is interested in using was not tested with insulation. Like I said, some of the assemblies will allow insulation to be installed, but you have to add an additional layer of gypsum type X, 5/8 type X. The insulation we'll get calls periodically regarding questions, regarding that. Typically, insulation could be removed from an assembly and not really affect the endurance rating. However, adding it becomes a bit trickier, especially if it's being added directly above the protective membrane in the ceiling, because insulation typically helps to trap the heat or impede the heat movement through the, from one side of the insulation to the other, thereby intensifying the heat. And if it's installed right at the ceiling line or above the protective membrane, you could end up with premature failure of that membrane and not meet the fire endurance rating of that assembly. There are ways around that. One would be if the assembly was tested without insulation and with a 12-inch deep truss, and you wanted to include 3 inches of insulation, whether that would be for thermal or sound requirements. I know I've seen where they've gone with, okay, if you go with a 16-inch deep trusses and install a layer of 4 inches of insulation up at the underside of the floor decking, that still allows you with a 12-inch plenum space between the ceiling membrane and where the insulation starts, and so you still have your 12 inches, which would meet the requirements of the original test. But again, that's information that needs to be discussed with the building designer, and then obviously in particular, then the building designer needs to sell that, if you will, to the code official for final approval. And again, the IBC in section 703.3, method 4 and 5 does permit modifications to the assemblies. However, as I just said, this would include modifications involving insulation, but rational design must be provided to the building official for his or her final approval. Method 2, prescriptive designs. In the IBC table 721.1 para 3, there is a whole list of prescriptive designs, and of those there is one that describes a 1 hour prescriptive rated floor and roof assembly that includes wood trusses. And what we've got on this slide is basically just the general requirements of that assembly. So in this case, you're directly applying 2 layers of 5/8 type X gypsum board to the bottom chord of the truss. The floor sheathing has to be minimum 1/2 inch thick wood structural panels, and that can be plywood or OSB as defined by the building code. It has to be glued in this case and attached with 8-penny nails at right angles to the truss or joist. Maximum spacing is 24 inches on center, and then the assembly gives the requirements for attaching each layer of the gypsum. The number of screws, the type of screw, the length of the screw, the on-center spacing. There's also whereas the U.S. code only has really the one for trusses, the Canadian, their national building code, actually provides a very extensive list of prescriptive assemblies that include metal plate connected wood trusses in tables A 9.10, 3.1.B. And that can be a very good source for building designers who want additional information on prescriptive assemblies that have been tested for 1 hour. Canadians may use metric, but when it comes to the test and the 1 hour rated assembly is still a 1 hour rated assembly. So just something to keep in mind. Method 3, calculating the design. The IBC section 722.6 allows fire resistance calculations for wood assemblies. Basically, that's going to include the protective membrane, the framing members, other items that are going to be within that plenum, and then add those up and come up with a fire resistance rating for that assembly. Notice it does not include the unexposed membrane, such as the floor sheathing, is not included in the calculation. And again, looking in the building code, there are tables that list the maximum fire resistance rating that is allowed for the various products. And notice this calculated method is limited to fire endurance ratings of up to 1 hour. But in this case, we've got on this slide table 722.62, the time assigned to wallboard membranes. And if you notice, there's an additive method here where a 1/2 inch gypsum wallboard is good for 15 minutes. If you combine two 1/2 inch gypsum wallboards, you are now good for 40 minutes. So it's not a 1 + 1 = 2. In this case, it's really a 1 + 1 = 3. Before I go on too, I want to make sure everybody's clear, and forgive me if I'm preaching to the choir, but the differences between gypsum type X and type C. Many times what you're going to find in these assembly tests is they'll specify, certainly when you get into the 2 hour assemblies, they're specifying a type C gypsum. The type X gypsum was developed back in the 1950s, and basically what that is, it's standard gypsum or calcium sulfate, but it's also typically has some type of glass fibers in it to help reduce the shrinkage of the gypsum as heat is applied to it. Calcium sulfate, the gypsum has about 50% chemically bound water in it, and so as you heat the gypsum, that water is boiled off, and as it boils off, the gypsum typically shrinks. And so if you're using it in a ceiling application, the gypsum is going to shrink, opening up the cracks between the joints and allowing the flame and heat to get up into the assembly. So the type X with the fiber reinforcing helped stabilize that gypsum panel. And just tests on the gypsum itself, the literature I've seen, the type X basically is going to help increase the protection by about 4-fold in terms of if you were using, compare it with you were using just regular gypsum panels. Now the type C was developed in the 1960s, and that typically has the fiber reinforcing, and then they usually will add some other type of material that helps reduce the shrinkage, further reduce the shrinkage of the gypsum as you're applying heat, whether that's a vermiculite, which expands as you apply heat to it. But again, what they're trying to do is keep that panel as stable as possible. And so what's typically going to be found now is the type C gypsum is typically specified on most fire resistance rated floor ceiling or roof ceiling assemblies. Type X is commonly used in wall assemblies. If you have a copy of an older version of our document, you'll notice that it was, or if you go back to the older versions of UL or the Gypsum Association's Fire Resistance Manual, a lot of times it was specified as proprietary type X, which was in parentheses meant type C, because the original developer of the type C, I believe it had to do with a kind of a patent, you know, what they call that product. And so those that came to the game a little bit later had to come up with a different. But now pretty much everything is listed as type C for floor sealing or roof sealing assemblies. In our document, and if you look in the UL or the Gypsum Association documents, if they specify type X, they still mean type X. But now they'll say type C. You won't see proprietary or improved type X. It'll be just say type C. Method 4 is a comparison method, and the IBC allows the determination of fire resistance ratings based on a comparison of building element, component, or assembly designs having fire resistance ratings as determined by the test procedures set forth in ASTM E119 and UL 263. The combined with the provisions of IBC 104.11 listed in item 5 allow the building official to approve a design that complies with the intent of the provisions of this code, and that the material method of work offered is, for the purpose intended, at least the equivalent of that prescribed in the code in quality, strength, effectiveness, fire resistance, durability, and safety. Method 4 was basically used in developing the research report SRR number 1509-02, which is the calculated 2-hour fire endurance assembly. And here's a kind of a color of what that, or colored illustration of what this looks like. That assembly has a fire rating of 2 hours and a finish rating of more than 90 minutes. Now, finish rating is a term that's used to describe the protective membrane, which in this case would include these 3 layers of type 5/8 inch type C gypsum. And in order to get a 90-minute finish rating, those 3 layers acting together, they're thermocouples that are during the fire test that are installed at various locations in this, or along the assembly and within the assembly. And the finish rating typically is you're looking at 2 things: the any one thermocouple, the ambient temperature, or excuse me, the temperature at any one thermocouple located basically at the interface between that inner layer of, or the uppermost layer of the gypsum in this case, and the bottom of the truss cord. Any one thermocouple at that location cannot increase in temperature more than 325 degrees above its ambient temperature when the test started. So if it started at 70, it can't increase the temperature at any one thermocouple at that interface cannot increase by more than go up more than a temperature of 395 degrees. And then on average, all the thermocouples in that assembly at that interface can't increase more than 250 degrees above the ambient temperature. So again, if you're interested in the 2-hour calculated method, and there are 2-hour tested assemblies as well, but I would refer you, for the calculated assembly, I would refer you to the 1509-02 SRR report. The comparison method is based on Harmathy's 10 rules of fire endurance rating. We won't take the time to go through that during this presentation, but if you're interested in more information, I would suggest you consult sections 4-13 from the Society of the Fire Protection Engineers Handbook for more information. Method 5, like we said, is then alternate methods and materials that's allowed in the building code. And the highlighted and bold at the bottom of that paragraph, and I won't read it for you, but basically you can see that fire resistance is one, where alternate materials, design, and methods of construction are permitted. So the alternate materials and methods allows for other methods of developing a design by an approved source that complies with the intent of the code, and unless it can be demonstrated not to comply with the code, should be approved by the building official. And then, as I said before, in the latest and greatest version of the IBC, the 2015, assemblies are also allowed if they are approved or certified by an approved agency. So in conclusion, as far as fire-rated assemblies are concerned, the building designer must submit to a code jurisdiction a fire resistance rated design that incorporating metal plate connected wood trusses using any of the 6 methods allowed in section 703.3 of the IBC. If it's not a listed design, the building designer should submit details regarding how the submitted design was determined and show how it complies with the intent of the building code. For the truss manufacturers that are on this call, this is obviously outside the scope of what you're doing. Unless you're involved in design build, this is not something that you're going to get involved with. However, knowing this information, I think you can certainly help out your customers, certainly by helping them with the documents that SBCA offers, by having a copy of the this SRR 1509-01. When you get a set of construction documents and where it's specifying rated assemblies, certainly if it's a tested assembly, you can then go and look and see, well, what's kind of the basics of that, and then make sure that your truss designs are going to meet the requirements in terms of the minimum depth and maximum on-center spacing and so on and so forth. And if not, you can obviously bring that to the attention of your customer and or the building designer. Some of the reference documents that are used in or cited in the report are listed here. We've talked earlier about the National Building Code of Canada, again, as a great source for many of the, or for several additional prescriptive assemblies involving metal plate connected wood trusses. And again, as I said earlier, if you end up going to the our website and download a copy of the report, the links in the report are hot. So in other words, every one of these that are underlined in red should take you to directly to that website or to that document. Okay, so let's talk a little bit now about fire retardants and truss design. Fire retardant treatments are typically applied to building materials such as dimension lumber, and then many times you'll see that then referred to as fire retardant treated wood, and plywood to reduce the ability of the wood to fuel a fire. This treatment can allow FRT materials to be used as an acceptable alternative for building code requirements that specify non-combustible materials in specific applications. Now, I want to make sure everybody understands, however, that FRTs do not make the wood non-combustible, at least from the definition that's used by the building code. However, what they do is they definitely, or they greatly reduce the ability or the flammability of the treated wood, thereby limiting its contribution to the growth of the fire. In fact, FRTs actually, they lower the temperature of combustion for the wood. And what that does is then the wood will quickly form a charred layer, and that charring acts as sort of like an insulator, and it greatly slows down the rate of combustion of the wood. So the FRTs actually reduce the temperature of combustion, and wood chars faster, and then that slows down the rate of combustion. So while reducing the flammability of the wood, the fire retardant treatments may also cause degradation of the structural properties of the wood, which needs to be taken care of or considered in the design. Depending upon the type of treatment that's used, FRTs may require a reduction in the design values of the wood materials, a reduction of the capacity of the fasteners and connectors that are used to attach the wood materials. For trusses, that would be the connector plates. And in some instances or applications, it may also require additional protection for the fasteners and the connectors. So that's why it's fairly important to know what type of fire retardant treatment is being specified and how to use that in the design of whether it's trusses, I-joists, whatever. Code requirements related to the fire retardant treated wood are located in two places in the International Building Code. Chapter 6 basically details the various occupancies and construction types that allow the use of fire retardant treated wood. And again, some of the non-combustible application or construction types such as type 1 and type 2, there are instances that fire retardant treated wood is allowed to be used, and we're not going to get into those various instances during this presentation. But then also chapter 23, which is typically the chapter on wood design in the IBC, this is where you'll find information in terms of what the requirements are for FRT, the labeling requirements, design, the reduction requirements, and so on and so forth. And we'll spend a little bit of time now looking at those. So section 2303.2, fire retardant treated wood section, has several subsections. 2.1 discusses if the fire retardant treatment is a pressure process where the wood is basically, the wood materials are put in a cylinder and they're, through pressure, the treatment is impregnated into the wood. 2.2 includes other means during the manufacture of the product. So not just pressure impregnated, there are maybe other means that are allowed. 2.3 talks about the type of testing that's required if it's an other means during manufacture. So 2.3 and 2.2 go hand in hand. Section 2.4, 2303.2.4 discusses the labeling requirements that each piece of wood has to have on it so that those using it can understand what the treatment is and how it's to be used, or how the product is to be used. 2.5 talks about the strength adjustments. Subsection 5.1 talks about the strength adjustments for wood structural panels, and 5.2 would be for lumber. 2.6 basically talks about exposure to weather, damp or wet conditions, and this would be typically exterior applications. 2.7 talks about the requirements for labeling it as for interior applications. And then 2.8 talks about what the maximum moisture content for the product is after the treatment has been applied. And then 2.9 refers you to the type 1 and 2 construction applications. So fire retardant treated wood is defined in the code then as it has to have a listed flame spread index of 25 or less when tested in accordance with an ASTM standard E84 or UL 723. And again, this index basically is measuring the burn characteristics of the particular product and how quickly the product burns and how quickly that flame propagates along the surface of that product. And in this case, a spread index of 25 or less is termed Class A, and that's typically what you're going to see with fire retardant treated wood products. think the best I've seen for a non-treated wood product is 35, which would be a Class B. And there are several different untreated wood products that meet those requirements. But again, the code would say that, okay, if you want to use this product in this application, it's got to be a Class A flame spread. So that's typically going to be a fire retardant treated wood product. In addition, and that's a 10-minute test basically, they measure the propagation of the flame spread. An additional requirement is that it has to show no evidence of significant progressive combustion when the test is continued for an additional 20-minute period. And this would basically typically has to mean, or it means is basically the flame front cannot progress more than 10.5 feet beyond the center line of the burners at any time during the 30-minute test. Okay, labeling. A lot of information is supposed to be on the label, and again, that helps the end user know exactly if they've got the right product or if the right product is being used. Some of the things that need to be on the label would include the identification mark and of an approved agency. And in this case, that approved agency would be Underwriters Laboratory in the example I'm showing here. Identification of the treating manufacturer, this is Hoover, as you can see. The name of the fire retardant treatment, it's their PyroGuard. The species of wood that's being treated, in this case it's southern yellow pine or southern pine. In this case, another information would be flame spread and smoke development index. Flame spread is 10. Remember, we need to have at least no more than 25. So this flame spread, in this case, for this product, certainly meets those requirements. Smoke development, in this case, is 20 to 50. And these all numbers, depending on the code and the application, will determine if you can use this product in those applications. The method of drying after treatment, that can be very critical. In this case, it's really hard to tell, but this was, you can see here, KDAT and kiln dried after treatment. And then conformance with the appropriate standard in accordance with 2303.25 and 2303.2.8. In this case, they have, this is an older label, NER, there's an NER report for this product, NER 457, and that would be a code evaluation report through it would now be an ICC evaluation report that you would go and take a look at that, and that will give you much more information about this treatment and what the strength properties are and how the strength properties were produced. And then finally, if this product were to be used in applications that are exposed to weather, damp, or wet locations, it needs to include the phrase, no increase in listed classification when subjected to the standard rain test, ASTM D2898. Again, that would be for an exterior application. In this case, this doesn't have that on there. So in looking at it, one would assume, and rightfully so, that we are looking at a interior application only. Okay. Now, section 2.5, strength adjustments. The design values for untreated lumber and wood structural panels would be adjusted for the fire retardant treated wood. These adjustments to the design values have to be based on approved methods that take into consideration the effects of the anticipated temperature and humidity to which the FRTW will be subjected, the type of treatment, and the redrying procedures. And then the code lists a whole bunch of standards, and we're not going to go through it, but just know that the treating company would use these standards to develop the adjustment factors that they then publish so that the end user, whether that's the building designer or the truss designer, would then apply those reductions to the various properties of the wood and of the connections. Another thing that's critical with FRT is that the fire retardant treated wood needs to be dried to a moisture content of 19% or less for lumber, and wood structural panels 15% or less after they've been treated. Many of these are water-based, or I believe they're all water-based, and so then the product has to be re-dried down to what's considered a dry use application, or dry use moisture content, which for lumber is 19% or less. For kiln-dried after treatment KDAT, the kiln temperatures cannot exceed the kiln temperatures that would be used for untreated material. Because again, temperature is pretty critical here, and remember the FRT treatments reduce the temperature that combustion starts in the wood, so reduce the combustion temperature of the wood. So again, that's why some of the limits for how much or how high the temperature is when you're redrying the material back down to after it's been treated. There's also requirements in the code that talk about fasteners, connectors in contact with preservative treated and fire retardant treated wood. 2304 10.5.3 talks about fasteners for fire retardant treated wood that's used basically in exterior applications. And there you basically have to go with some type of a protection, or stainless steel, silicon bronze, or copper. And you know, that protection is typically in the way of a hot dipped zinc coated galvanized steel. And if you're using connector plates, then those in terms have to be mechanically, or you're allowed to use mechanically deposited zinc coated steel. Now, typically for interior applications, you don't have to do any, or you need to refer to the chemical manufacturer, the treating companies' recommendations. And if they don't have any, well, then the code kicks you back to 10.5.3 and using some type of a galvanized steel, or, like I said, stainless steel, silicon bronze, or copper. There's additional information in the National Design Specification for Wood Construction that basically includes in Chapter 2 for fire retardant treatment reductions for the material itself, and then also in Chapter 11 for connections. And basically the effects of, and this is reiterating what's in the building code, the effects of fire retardant chemical treatment on strength shall be accounted for in the design. Adjusted design values for the material or the connections have to be obtained from the company providing the treatment and redrying service. And with FRT, they can be very brittle, and so they fire retardant treated wood should really never be used in applications where the low duration factor would exceed 1.6. So definitely don't want to use it, say, in impact type of applications, or where the material could be subject to impact loads. For metal plate connected wood trusses, there's also additional information that's provided in ANSI TPI 1, which is the design standard for metal plate connected wood trusses, which is a referenced standard in the building code. And again, it talks about the requirements for the identification. The lumber that's used in the trusses must be identified by a quality mark of an approved inspection agency, identified by a label affixed to the package. The FRT lumber used in trusses shall be re-dried after treatment to 19% maximum moisture content at temperatures not to exceed 160 degrees. Now, the trusses are not manufactured and then shipped off to the treater. Typically, the truss manufacturer is going to have to, they're probably not going to stock fire retardant treated lumber in their inventory, so what they'd have to do is send material or obtain material and then design the trusses with that treated material. And so the material they're using has to be no more than 19% moisture content. The metal connector plates then also, what the grip values are, lateral resistance values, or the plate grip values for biting into the wood, those reductions have to be as specified by the chemical manufacturer. And again, the quality mark shall indicate the design value adjustments are in accordance with either the FRT manufacturer specifications or based on approved methods which are included in the building code. So just to reiterate, both NDS and ANSI TPI 1 are clear that applicable adjustments, if you're using FRT for the lumber, those adjustments to the design values have to be provided by the material supplier. And all FRTW material suppliers typically do provide those reductions. Got a report that I'm looking at here from Hoover, ESR 1791, that has tables in it that list the various reductions based on climate zone and for different species. And so it's that information that is going to be used to be applied to the design values for the lumber to reduce those values to take into account the effects of the treating. And again, some of those properties that are typically affected would be compression parallel to grain, horizontal shear, tension parallel to grain, bending, modulus of elasticity, bending strength, and fasteners and connectors. So, specific to trusses, if a job is specified that requires the fire retardant treatment to be, or fire retardant treated lumber to be used in the trusses, the building designer is responsible for determining if the trusses need to be designed and built with fire retardant treated wood. Okay, section, chapter 2 of TPI 1 is typically referred to as the design responsibilities chapter, and section 2.3.2.4, paragraph G6.3 of that requires that the construction documents include information concerning moisture, corrosive chemicals, and gases expected to result in corrosion potential from wood treatments or other sources that can be detrimental to the trusses. So, assuming that information is included in the construction documents, then typically what the recommendation is the truss manufacturer and their design department would contact the truss design engineer and or the metal connector plate supplier, who typically is the one that has whose software, the design software that they're using. And they ideally would discuss the truss application and treatment being specified before bidding the job. This allows a truss design engineer and or plate supplier to determine the design criteria and connector plate type to use to design the trusses. Now, keeping in mind we're talking about trusses and the connector plates. However, if additional protection is required to the plates, there's a good chance it's also going to be required for other steel components or all the steel components that may come in contact with the trusses, such as nails, hangers, straps, that type of thing. And typically, hopefully this would be specified in the construction documents, but there are many truss manufacturers that help, or they also sell and provide the hangers and the straps, and so they want to make sure that that information is getting out into the field. Exterior exposures with metal plate connected wood trusses should typically be avoided. It's not that they can't, the trusses certainly can be designed for those applications. The concern is when you get into exterior applications, there's a continuous wetting and drying that's taking place of the wood. Wood's a biological material, so as it gets wet, it's going to expand or swell, and then as it dries, it shrinks. And the problem is that you have a continuous wetting and drying, continuous swelling and shrinkage, and eventually that could help loosen the connector plates. Since most of the connector plates used today, the tooth length is only about 3/8 of an inch to 7/16 in length. So that's why exterior exposures really are not a very good idea with metal plate connected with trusses. A couple more items here and I'm done. Additional information, okay, if the project specifications require the use of a specific treatment, but after discussing with the truss design engineer or the plate supplier, it's decided we'd like to go with a different, well then obviously the truss manufacturer needs to consult with the customer and the building designer for review and approval of any treatment substitution. Adjustments to the design properties of the lumber and the connector plates to account for the type of treatment and design conditions are typically applied utilizing an inventory of the treated lumber that's already in the design program. However, it can also be manually applied by adjusting the durational load factors, or typically is applied by adjusting the durational load factors of the lumber and ladder resistance values for the plates. The best way to do that, again, for the truss designer is to discuss these procedures with the truss design engineer and the plate and software provider. It's recommended that the truss manufacturer also provide material safety data sheets for the treated lumber with each truss shipment so that the installers know what the type of product they're working with and any other safety information that needs to be they may want to take into account when they're handling this material. So finally, in concluding, fire-retardant treated materials can be incorporated into buildings to reduce the ability of lumber products to contribute to a fire. The IBC requirements dictate where and under what circumstances fire-retardant materials are allowed. When designing trusses with fire-retardant lumber, ANSI TPI 1 should be followed as a guide for the appropriate drying conditions for the lumber after treatment, and then in addition, appropriate design value reductions for the lumber or connector plates should be taken following the FRT manufacturer's specifications. And with that, does anybody have any questions or comments? Well, hearing none and seeing none, thanks everybody. Hope you have a